morning, everyone. Very good. Hope everyone is good. Fine. कैसे हो सभी लोग? Kishore, how are you? Nitin, good morning. Everyone, good morning and very warm welcome to the class. So, let's get started. Anyone, anything to say? Nikita, good morning. सब मजे में हो ना? सभी इंजॉय कर रहे हैं ना? एग्जाम में टेंशन तो होता है यार. दैट्स द नेचुरल पार्ट ऑफ appearing in any kind of exam. Even schools में जब exam होते हैं, some sort of burden stay with us. So exam has that very nature. It will bother us, but again, we have to just take that pressure positively. क्योंकि अच्छा बहुत सारे एग्जाम्स. चलो कोई नहीं. क्या है ना, एग्जाम है. अब उसके प्रेशर को पॉजिटिवली लेना है. सम प्रेशर आल्सो यूज्ड टू बी पॉजिटिव, सम यूज्ड टू बी नेगेटिव. सो अगर बिल्कुल भी प्रेशर फील ना हो तो भी लगता है यार कुछ तो मसला चल रहा है, कुछ भी प्रेशर नहीं हो रहा. सम प्रेशर शुड बी देयर स्टिल. सो लेट्स एंजॉय दिस प्रेशर आल्सो. Done. Let's start with a question. I told earlier in the previous class that I will be starting with a question from rotation. Done. So एक question है rotation का, and after that we will be starting with the modern physics. So here is the question on your screen. Take some 3 minutes of your time and do it. Again, question is very easy. You only have to deal with the concept of torque calculation. That is R cross F. Done. If you know that properly, you will be able to answer it. So look at the options carefully, question carefully, and do it.
Good morning, ma'am.
Very good morning. Good morning. Good morning. Nikita, one option is correct, first one. Second one, you need to reconsider. Just check once more. I feel you have taken another option because you are taking one direction of force. Also take another direction of force at that point, because at that point force can have two directions. And so torque can have also two directions, clockwise and anti-clockwise. So just consider that, Nikita. चलो डन है, मैं करती हूँ. So what the question is, there is a wheel. Wheel is kept like this. You can see here, its radius is r, mass is m, placed at the bottom. A constant force is continuously applied on the surface of wheel so that it just climbs the step without slipping. Then there is no slipping happening anywhere. Consider the torque tau about an axis normal to the plane of paper passing through point Q. So all calculations of torque we have to do around which point? Around point Q. Which of the following options is correct? It means what is happening? We are just trying to rotate this wheel by applying torque at different point in this sense. Done? So that it can climb up and rest on this surface. Done? And we are doing torque calculation we have to do through the point what? Q. So when we are trying to lift the this is a wheel, lift the wheel up on the surface, at that in that duration, what we have to be careful about, we have to be careful that this Q point will always remain in rest. Done? Because around this point we are just lifting it up there. ठीक है? तो चलो देखते हैं. So what will happen? First option is what? Option ही देख सकते हैं. Nothing else we have to do in this question now. So first option is, if the force is applied normal to the circumference at point P. Force is getting applied normal to the circumference at point P. So if normally force is acting, then force is acting normally. And here you can see this force is passing through. If we extend this force will pass through point which? Q. And Q is the point of rotation here. Done. So my force is passing through the axis of rotation. It means what? It means torque because of force acting normal to the circumference at point P will be what? 0. So first option is what? Correct. First option is what? Correct. Right? Now what for the second option? If the force is applied tangentially at point S, तो चलो अब हम लोग किस point पे चलते हैं? Point S पे चलते हैं. और point S पे हम लोग force लगा कैसे रहे हैं? Tangentially लगा रहे. तो चलो आप force को ऐसे लगा लो. Tangentially मतलब ऐसे. अब मुझे अगर if we are lifting this up on the surface, torque should be in what sense? Torque should be at this point, like force must act like this. Why? That we will see later. But for now, just let's see at which point, around which point we have to calculate the torque, that is Q. So, and line of action of force is this. So line of action of force is this. Axis of rotation is this. R cross F we have to calculate the torque. So what will happen? R cross F. So if you just see that will move something like this. जैसे यहाँ पे देखो, can you imagine here if torque is acting like this, will this wheel climb up the surface? Anyone? Will this wheel climb up the surface? Torque is not going to be 0. Done? That is for sure. But next statement is also there, but the wheel never climbs up the step. क्या ये step climb करेगा? Yes, it will climb. It can climb, right? है ना? आप इसको just imagine करके देखो. Just close your eyes and imagine what will happen if torque is acting like this. That will climb up, right? So this statement will become wrong क्योंकि यहाँ बोला है it won't but the will never climbs the step. No, it is not going to happen. Now let's look at the option C. If the force is applied at point P tangentially, so earlier at point P force was getting applied along the normal, and now in this question what is happening, force is getting applied tangentially at point P. So चलो यहाँ पे tangentially एक force लगाते हैं. Now if we calculate R cross F, it will be this R cross F, done like this, and as this will start climbing up, what will happen, this point P will also rise up, है ना. जैसे if I am going to draw the diagram, I am very poor in diagram, that is why I don't draw very often. तो देखो यहाँ पे तुम्हारा कुछ ऐसे दिखेगा ना, धीरे धीरे वो ऐसे क्लाइम करेगा ना, it will leave the surface, right? As this will start climbing up the step, what will happen? It will gradually leave the surface, will be in air for some times, and then it will get up somewhere here. So what is going to happen during this period of time? If we consider here the torque, because of this force, this torque will be not zero, first thing. Second thing, how the magnitude of this torque will change if this is climbing up. It means what will happen? Which was R here, R was this was R now, R cross F we have taken. So here R was the diameter initially. Now if it is climbing up, this R vector will change. How? This R vector will change something like this, है ना. So this R is becoming what? Now, matlab gradually force will look something like this, then force will look something tangentially like this. So this R is going to what? Decrease. It means what? Tau decreases continuously as the wheel climbs. Yes, it will be true. क्योंकि tau का value क्या होगा? R cross F. R और F के बीच का angle will always remain 90 degrees. So this is RF sin 90, but this R value is going to continuously decrease. Then distance of that point from the axis of rotation will continuously decrease. So that is why torque will decrease. Now, if the force is applied normal to the circumference at point X, similarly at point X, if normally force is getting applied, so normally means force is getting applied like this. So this is the line of action of force. What is the distance of this line of action of force from the axis of rotation point? This distance, perpendicular distance, it is this. Now what the option is, if the force is applied normal to the circumference at point X, then tau is constant. No, tau will not remain constant because as the wheel will climb up, this distance, this point X will rise up. और अगर आप imagine करो ना, so this is the line of action of force. Done. And as it will go up, what will happen? This line of action of force will come down. And it will move more towards point O. Then it means this R distance is going to change. Done. So that way also you can check. You can simply draw the line of action of force and you can see with rotation what is going to happen with the distance of that line of action of force with the point of axis of rotation. Done. So this tau is not going to remain constant. So the correct option will be A and C. Okay. So simply you needed to deal with the top thing. So this question you should have done. If it is coming in the exam, you would be doing it, right? I hope. चलो डन है. अब हमारे पास है मॉडर्न फिजिक्स. वी हैव अ ह्यूज प्रोजेक्ट. इसमें चीजें याद बहुत रखनी है. वी हैव टू कीप सो मेनी थिंग्स ऑन आवर हेड, formulas, concepts, and at the same time, how to simplify the calculations also. That thing also we have to keep in our head. So the very first question is here on your screen. I am giving just 1 minute. 1 minute I will be giving for each question. So everyone just stay prepared with calculation. कि जल्दी से करना है. Just be with more energy. Do it now. Yes, correct. चलो जल्दी, फास्ट एवरीवन। कम ऑन। नितिन, निकिता, ऋषभ, सोम, तृप्ति, कम ऑन यार, डू इट। अगर फॉर्मूला याद नहीं है तो चलो फिर हम लोग रिवाइज करते हैं। सो व्हाट द थिंग इज, बट आपने जी मीन्स के टाइम में पढ़ा होगा ना, इट मस्ट बी देयर इन योर हेड, राइट? यस जय। Done. That factor will come into account. Correct. So what the formula is, for wavelength, what formula we write? 1 by lambda equal to RZ square, 1 by N1 square minus 1 by N2 square. Then this is the formula, or here I have written already. So this is the formula that we need to remember here. If transition is being made from N1, from N2 equal to N1, then our wavelength formula will look like this. What is this? Z. Z is your atomic number. And this formula is true for what kind of element? Hydrogen-like element. Hydrogen-like atom कहने का मतलब which will have one proton in nucleus. Sorry. हाइड्रोजन लाइक कहने का मतलब क्या है हमारा? जैसे हाइड्रोजन के पास क्या होता है? एक इलेक्ट्रॉन होता है, एक प्रोटॉन होता है, ठीक है? तो हाइड्रोजन लाइक एलिमेंट, जैसे आप He+ ले लो, He+ में क्या है? हीलियम का एटॉमिक नंबर कितना होता है? 2। सो He+ का मतलब क्या हो गया? इसके पास एक इलेक्ट्रॉन होगा, 2 प्रोटॉन होगा। तो हाइड्रोजन लाइक एलिमेंट कहने का मतलब क्या है? ऐसा एलिमेंट जिसके पास सिंगल इलेक्ट्रॉन होगा। डन। So that is your hydrogen like. Again, you just needed to use this formula. So in our question, what was given? Given thing was hydrogen atom. So this thing is going to remain same for all these 4 things, ना? चारों के लिए सेम रहेगा क्योंकि transition is being made from 2 to 1. So this is constant. So we simply need to check with Z square. 1 by lambda is lambda will be inversely proportional to what? 1 by Z square. Done. So जिसका Z ज्यादा होगा उसके लिए wavelength क्या होगा? छोटा होगा. So the shortest wavelength you're going to get for which one? जिसका Z ज्यादा होगा उसका wavelength छोटा होगा. Yes. So Z is more for which? Hydrogen 1, deuterium 1, helium 2, lithium 3. So lithium. Done. So the correct option will be what? D. चलो फॉर्मूला याद होना चाहिए. प्लीज रिमेंबर दिस फॉर्मूला, डोंट फॉरगेट दिस Z स्क्वायर. ठीक है, चलो नाउ दिस क्वेश्चन अगेन. 1 minute आई एम गिविंग. क्योंकि ahead when we will be doing questions ना tomorrow, we need all this formula in our head, everything. Okay, so ठीक है, rest people please, come on. Which formula, Rishabh, you're talking about? N is number of electron or proton in form. अच्छा, previous one. यार N is what? N is number of cell ना. जैसे तुम्हारा ओके निकिता, एन में कंफ्यूजन कैसे हो रहा है यार? एन जो ये वाला क्वेश्चन था, ये क्वेश्चन तुम्हारा क्या है? दिस इज n equal to 1, that is orbital number, n equal to 2, n equal to 3, n equal to 4. So if electron is transitioning from n equal to 2 to n equal to 1, then during this transition we get a photon now, and that photon will have certain frequency, certain wavelength. So that wavelength we can calculate by using this formula, where n1 n2 is what? N2 is the higher energy state and n1 is lower energy state. Done. So if it is going from 2 to 1, then here n2 का value 2 होगा, n1 का value 1 होगा. If it is transitioning from 4 to 1 or 4 to 2 suppose, so n2 will be 4 and n1 will be 2. So we need to look at the transition. N is orbital number, yes. EY n का स्क्वायर ये कहाँ है ऋषभ? एक सेकेंड, यू कैन अनम्यूट योरसेल्फ.
E by n स्क्वायर का फॉर्मूला नहीं होता जहाँ E 13.6 होता है.
क्या क्या आप एनर्जी की बात कर रहे हो क्या?
Yes ma'am.
Which formula you are talking about?
Ma'am, energy levels formulas. Like
So,
first
आप इनकी
energy level is
this formula you are
13.6.
talking about, right?
En is equals to minus 13.6 over 9 n square.
Sorry, can anyone explain what he's saying? Fast.
मैम एनर्जी लेवल्स जो होते हैं ना,
हाँ हाँ
तो उसकी जैसे कि लेवल 1 की एनर्जी होती है ग्राउंड स्टेट की, वो होती है -13.6.
हाँ हाँ.
देन जो सेकंड लेवल पे होती है वो होती है -13.6 डिवाइड बाय 4 2 का स्क्वायर.
Into z square by n square. Yes.
यस मैम. मैम ही सेड दैट.
अच्छा, वो फॉर्मूले की बात कर रहे हो तुम. ठीक है, डन. सो यहाँ पे क्वेश्चन का आंसर सारे लोगों ने ऑलमोस्ट बताया. डन. नाउ लेट्स गो विद द कैलकुलेशन. Tripti, you must be doing somewhere wrong. So what the question is, as per the Bohr model, the minimum energy required to remove an electron from the ground state. Ground state का मतलब क्या होता है? n equal to 1 is termed as your ground state. Done. And we have to ionize it, remove an electron from ground state of doubly ionized lithium atom. So यहाँ से इलेक्ट्रॉन को रिमूव भी करना है, यानी कि बाहर लेकर आना है. So बाहर लेकर आने का मतलब n का वैल्यू क्या हो जाएगा? इंफिनिटी. डन. So what will be the initial energy? What is the energy formula? Energy formula is -13.6 z square by n square in term of electron volt. Done. So this is energy formula. Now for n equal to 1, what will be the energy? That will be -13.6 into z का value is what? 9. Z का value is 3, so z का square 9. Now finally what will be the energy at n equal to infinity? So आप वैल्यू क्या रखोगे by n का वैल्यू infinity. Done. So anything by infinity is what? 0. So finally its energy is 0. Initially its energy is how much? -13.6 into 9. So if you are going to do how much value you will be getting? You will be getting D only ना. सारे लोगों का C कैसे आया? Nikita, you are correct. So 13.6 into 9 will be equal to how much? 4 point, और ये हो जाएगा आपका 2 और ये 1 2 अगेन दिस मच इलेक्ट्रॉन वोल्ट. एक सेकेंड. Okay, answer I have not written, but that will be the answer now. How everyone were getting C? 14.8 कैसे आ रहा था? 40.8.
मैम स्क्वायर करने भूल गए थे, उसकी जगह सिर्फ एक बार 3 से
ये
मल्टीप्लाई कर
ये
दिया.
नहीं भूलना है ना. This is very important thing. You don't need to forget that at least. है ना? Calculation should not go wrong like this, yaar. Just be careful. So this will be the formula. Done. So here I have just summarized all the formulas. Energy formula is what? -13.6 z square by n square. Z is what? Atomic number of hydrogen like element. Then hydrogen like means electron it will have. Radius formula means for any nth orbit, this is first orbit, this is second orbit, and so on, third, fourth. So for nth orbit, radius formula is 0.53 n square by z angstrom. What is the velocity of electron in nth orbit? That will be 2.18 into 10 to the power 6 z by n meter per second. So these formulas are quite important. Yesterday in the class, I have given you this formula in terms of joule. So that was how much? 2.18 into 10 to the power minus 18 joule z square by n square. So everything you should have in your head. Chalo, done hai. Again, 1 minute you take and do this question fast. See, just be carefully. De Broglie wavelength का रेशियो पूछा है, ठीक है? यस, सारे लोग करो जल्दी से. So you also need to check with the option. Yeah, do carefully. Yes, Jay, that is correct. What is the question? There is a mass m done, and this is at rest. Just use a slide of mechanics here, and this is at rest. So its initial momentum is what? 0. Now it is decaying. So whatever thing is happening inside now. Just consider a case of bomb that we have studied. If a bomb is exploding, then what is happening? Because of its internal force, it is exploding now. So during explosion, if we are considering bomb as a system, then its linear momentum will remain conserved, right? Similarly, here this nucleus is at rest. Momentum is 0. Explosion is happening. Yes, Nitin. Explosion is happening because of decay is happening because of internal pressure, force, whatever it is. So its momentum will be conserved. It is decaying into two particles. So one particle, suppose it is M1 and another is M2. Why here I am taking M2? Because one particle should move in this direction, another in this direction, so that net momentum will be 0. So M1 V1 should be equal to M2 V2. And de Broglie wavelength is what? De Broglie wavelength formula is h by p. If momentum of both the particles are same, their de Broglie wavelength will be what? Same. Done. So the correct option will be what? C. यहाँ पे मैंने भी आंसर गलत लिखा है. This is C actually. ठीक है? Done. चलो, this is the formula, right? Now do this question again 1 more minute. डन है? चलो जल्दी से बताओ। अल्ट्रावायलेट रेडिएशन है ना, कब रिलीज हो रहा है? when electron is jumping from 4 to 3. So it's saying that in which transition we will get infrared radiation. Which radiation has more energy, infrared or ultraviolet? Energy of ultraviolet radiation is greater than energy of infrared, right? Just use this logic and get it done. चलो जल्दी से बताओ। नो, oh my god, so the correct answer will be what? You just see now, from 4 to 3, if electron is coming from 4 to 3, Tripti, yes. So if electron is coming from 4 to 3, we are getting what? Ultraviolet. Here we are getting UV rays. So in which transition we will get infrared? We already know that orbital distribution से हमें पता है कि energy difference between two consecutive orbits in decreases as we go up. As we go up the orbitals, energy difference between two consecutive cells decreases. जैसे energy difference between 1 and 2 is more than energy difference between 2 and 3. Similarly, energy difference between 3 and 4 is less than that of 3 and 2. So as we will go up, diagram से भी दिख रहा है, energy difference between two cells will continuously decrease. Done. So if to get infrared radiation, infrared means less energy. So less energy difference wala orbital we need to check. Done. So which one it will be? 2 to 1. Difference between 2 and 1 will be more than that of 4 and 3. So that won't generate infrared, right? 3 to 2. Again, difference between 3 and 2 orbital is more than that of 4 and 3. So again, 3 and 2 won't generate infrared. Then it will generate photon of energy higher than that of ultraviolet, right? Again, 4 to 2, that is not possible because between 4 and 2, energy difference is much higher than that of 4 and 3. We need less energy difference wala orbital here. So 5 to 4, definitely it can be. 5 to 4 will have less energy difference than that of 4 and 3. So it can be infrared. Rest can't be. Clear hai? So the correct option will be B. Zoom is not working properly. Once आप YouTube पे भी join कर सकते हो ना? Avanti Live 1 करके channel है. So if you type there, you will get the live class going on there. Once you can join there as well. Okay, so this is the difference I have just shown you here in the diagram. So what is happening? Energy difference between two consecutive cells is decreasing as we are going up. So this question was from here. Chalo, ठीक है. Here also I have given you the extra information like Lyman series we get na. When electron transition happens from excited to ground state, we get photon. Done. जैसे in the previous diagram, if suppose electron is here, done. So if electron is here, it can jump from, क्योंकि if anything is in excited state in nature, everything wants to reach to the ground state, है ना? Ground state means less energy state. Less energy state means more stable. So everything in nature wants to be more stable. It means if it has reached to a state which is unstable, it will try to reach to the stable state. So if it is at n equal to 3, it will try to reach to the stable state, that is to n equal to 2 or n equal to 1. Done. So if it comes to n equal to 2, suppose it will emit a photon of how much energy? Equal to the energy difference between third and second orbital. So here a photon will get released. Again, 2 is also not that much stable state. Again, it will try to jump to the first state. So again, here also a photon will get released. So if electron is at n equal to 3, it has two or three ways of coming to the stable state. First way is how it will first go to the second and then it will go from second to one, or it can do one thing, it can directly jump from 3 to 1. Okay, so how many different kind of photon it can generate? It can generate 3 different kind of photons in 3 different transitions. Done. But its ultimate goal is what? Ultimate goal is to attain a stability. Done. So from here, what kind of questions can come? It may ask you, suppose electron is transitioning from 7 to 1, from n equal to 7 to kahan jana hai usse? N equal to 1. So how many different kind of photon can be released? So how you will calculate that? There is a simple formula, permutation combination hum log yahan laga sakte hain. So I'm not going into the depth, but yes, formula is NC. So if 7 to 1 it is coming, you can just calculate here 7C2. And NC2 का formula तो आप लोगों को मुझसे better पता होगा. That is how much? N factorial by n minus 2 factorial 2 factorial, if I'm not wrong. This is correct, right? Chalo, ठीक है. So these things can come from here. Also, one more thing is कि if transition is happening from any excited state to the one, जैसे अगर आप यहाँ पे देखो कि if transition is happening, suppose my excited electron is in 6th orbit, 5th orbit, and 4th orbit, something kind of that. So what will happen? If electron is here and it is transitioning directly to the one. If electron is here and it is transitioning directly to the one. So if any electron from excited state is coming to the first state, that is to the ground state, then whatever photon is getting released, that photon has more higher energy, as you can see here. Kyunki to any excited state, if you are considering, and if ground state you are taking, energy difference between these two will be more. Done. So if transition is happening from any excited to ground, light getting emitted belongs to which region of a spectrum? It belongs to, it is called Lyman series, and it belongs to which region? Chalo koi bhi ek batao mujhe jaldi se. Lyman series mein, like if transition is happening from any excited to ground state, light is getting emitted. So this light belongs to which region? मैक्सिमम वेवलेंथ तब आएगा जब एनर्जी तुम्हारा कम होगा. ठीक है, एनर्जी का फॉर्मूला क्या होता है? एच सी बाई वेवलेंथ. तो वेवलेंथ मैक्स के लिए एनर्जी क्या होना चाहिए? कम से कम. सो एनर्जी कम से कम लाइमन सीरीज में कब होगा? जब 2 से 1 पे ट्रांजिशन करेगा. ठीक है, यस तृप्ति, अल्ट्रावायलेट रीजन में ये बिलोंग करेगा. ठीक है, इट विल बिलोंग टू व्हाट? अल्ट्रावायलेट रीजन. नाउ बाल्मर सीरीज. सो इफ excited electron is coming from anywhere to n equal to 2, n equal to 2 if it is coming, then we will get Balmer series, and this series belongs to visible region. Okay, this belongs to visible region. And if from any excited state it is coming to n equal to 3, then we will get Paschen series, and this belong to infrared. Again, bracket and T-fund series we get, and these two also belong to infrared region. Okay. So how the formula for what will be the formula for wavelength for each series? So that will be again equal to what? 1 by lambda equal to, if I'm considering here R मैंने लिखना छोड़ दिया. So R, if I'm considering here hydrogen atom, तो Z1 हो जाएगा, and 1 by what I will be writing? 1 by N1 square minus 1 by N2 square. Again for Lyman series, N1 will be what? For Lyman series, Lyman के लिए N1 क्या हो जाएगा? Finally वो कहाँ आ रहा है? 1. N2 क्या हो जाएगा हमारा? N2 will be greater than 1. Done? समझ रहे हो? And for Balmer series, N1 will be how much? It is coming always to 2 now. So N1 will be 2. And N2 will be what? Greater than 2. And so on. Paschen के लिए क्या हो जाएगा आपका? N1 3 and N2 will be greater than 3. Maximum minimum wavelength you can calculate. For maximum wavelength means minimum energy. So the least transition, yani ki for Lyman, minimum wavelength will be when transition will happen from 2 to 1. है ना? When it will happen, minimum wavelength. So energy more. No. Maximum wavelength hoga when transition will happen from 2 to 1. For minimum wavelength, energy should be more. And this is possible when electron is getting transition from highest cell, that is n equal to infinity to n equal to 1, then almost n equal to infinity. And so these things so you will do now. Chalo. So do this question now. Take 1 more minute and do it. This question, I guess, it came in your exam also, recent exam, I guess. चलो जल्दी से बताओ. It seems like आपने जी मेंस में मॉडर्न फिजिक्स नहीं पढ़ा क्या? पढ़ा होगा जरूर. चलो. What is the formula? If you have forgotten, please भूला मत करो. Kinetic energy का modulus is equal to total energy का modulus is equal to potential energy का modulus by 2. Then this is, and kinetic energy used to be negative, positive. Potential energy used to be negative. Total energy used to be negative. ठीक है? Kinetic energy can't be negative. Sorry. It is coming from excited state to the ground state. Done. Just now I have discussed the energy thing. Ground state means less energy, more stable, right? Once, okay. Check once more. Okay, Priti, so ठीक है. Okay, what's the formula if you remember? Planetary model से हमने ये formula निकाला था ना? If you correctly remember, तो potential energy का formula क्या था? Minus, sorry, why G I'm writing, sorry. What was the formula? K Z E into E divided by R. This was the formula now. R was what? Distance of orbit from the nucleus. Now do it. Look at the things carefully now. Blindly we should not go. Whatever these things you have got from where? This relation you have got from where? From the planetary model of Rutherford. है ना? वहां पे potential energy formula was what? Minus K JD into E by R. Just like जैसे potential energy of two charge system we calculate how? K Q1 Q2 by R. So if this is nucleus has JD positive charge, electron has negative charge, and distance between these two is R. So what will be their potential energy? Minus, क्योंकि electron has negative charge, minus K JD Q1 into E Q2 divided by R. So if electron in hydrogen atom makes a transition from excited state का मतलब क्या हुआ? Its distance from the nucleus will be more. So R is more. And if R is more, if I'm going to write here the kinetic energy, its value will be K JD square by 2R. So if R is more in excited state, R is more, kinetic energy will be what? Less. And if it is coming to the ground state, suppose here it is coming, then definitely R is what? Decreasing. And if R is decreasing, kinetic energy is becoming what? More. Done. So kinetic energy increase. It will increase. Now what about the potential and total energy? Remember that potential energy is negative. So if R is decreasing, magnitude of potential energy is increasing. But since it has negative sign, we will say that energy is what? Decreasing. We will consider negative sign. No? So its potential and total energy both are negative. In magnitude, both are increasing. But since they are negative, potential and total energy will what? Decrease. So options जो आपने C, D, D दिया ना, सारे ही गलत. Options will be what? Option will be what? A. And this question you got in your this exam also, I remember last week. ठीक है? So formula कहाँ से आया है? ये बहुत important होता है जानना. Otherwise you will be doing mistake. सबको clear है ना? Now do this question. Take some 1 more minute and do it. Again, be careful. Read the question and stay sensible while reading the question. ठीक है? X-ray tube and Mosler's law are the addition. ठीक है? ये हमें मेंस में नहीं पढ़ना, but X-ray production by Cooley's tube and Mosler's law are there in your GE advanced. Again, this is not a new topic, just a new name. Concept will remain the same that I will discuss again. But just now read this question, you can answer with whatever knowledge you're having in your head. Nitin, कैसे निकाला आपने ऐसे? Just look at the question carefully, my dear. In an X-ray tube, electrons accelerated through a potential difference of इतना strike a copper target. ठीक है, जो भी हो रहा है, copper target को hit किया. The speed of emitted X-ray. X-ray is what? X-ray is what? Light, no? And light has a speed of what? 3 into 10 to the power 8 meter per second. You don't need to calculate anything here. It is asking the speed of emitted X-ray. X-ray is what? Light. Its speed is what? This in vacuum. Done. And inside X-ray tube, there used to be vacuum actually. So speed will be of the range of 10 to the power 8. Chalo, theek hai. So this is your Cooley's tube. Now, how X-ray get produced actually? So, आपने modern physics में you must have studied one thing कि if there is an atom and this has an electron, and if we wish to knock this electron out, what we can do? We can do first thing, we can just heat this atom. And if we are heating this atom, its energy will increase क्योंकि energy का formula हमने पढ़ा है thermodynamics में 3/2 kT. T is in Kelvin. Done. So if we are increasing its temperature, energy of atom will increase. And if this energy is becoming so much enough that it becomes equal to ionization energy, this electron may come out. Okay. First thing. Second thing, we can allow light to fall upon it. Done. Of threshold frequency of enough energy that can knock this electron out. Because when light will fall upon it, what will happen? Here light will behave as a particle. So one particle of light is called photon, and between photon and atom collision occurs, and during this collision, photon transfers its energy to atom. And if that energy is enough, this electron will come out. Again, this is the second way. Third way is what? In electrostat, you must have studied. If we have a charged particle Q, suppose this is in rest, and I need a charged particle of certain energy E, suppose. Then so what I will do? I will do one thing. Suppose मेरे पास एक capacitor का plate था. This is a positive plate and this is a negative plate. So it has a potential difference between these two plates. It has electric field. Done. And if I am allowing this charged particle, which was in rest, to this is negative, to move from here to here, to get accelerated from here to here, what will happen? This Q charge will get attracted towards this negative plate. So it will start moving towards this. It will gain velocity. It means it will gain energy. Done. So if we have, suppose this capacitor plate is made of tungsten. Suppose it is made of tungsten, and we want to knock an electron out of an atom of tungsten from this plate. Then I have taken one plate made of tungsten. It will have several atoms of tungsten inside. I know this is made of tungsten, so millions of atoms of tungsten. Now what I am doing is I am bombarding a charged particle on this plate, and there was another plate here that is positively charged. So as this charge will move towards this, it will gain kinetic energy, more kinetic energy, more kinetic energy, and what will happen? The moment it is striking the plate, this Q charge has enough kinetic energy, very high, and they are colliding. During collision, energy transfer will occur. And if that energy transfer is enough to knock the electron out from tungsten element, what will happen? We will get electron. So that happens in our, or even if it is not knocking out the electron, what can happen? if energy is not enough to knock out the electron, what will happen? चलो मैं यहाँ पे diagram बनाती हूँ. So my electron is here, but it's not getting enough energy to come out of the atom, but it's getting energy enough that it can jump to n equal to 3, suppose. So it will jump to n equal to 3 after gaining that energy. But since it is at n equal to 3, again it will try to gain a stability. During that process, it will release energy while coming down. And if that energy belongs to X-ray, then we will get X-ray. Done. So here Coolidge tube में कुछ ऐसा ही concept होगा. Now what exactly is happening, that I will show you now. So this is a Coolidge tube. Again, you don't need to focus much on its construction. Basic things I will be telling you. This is a vacuum tube first. There is no other particles present in between. This is a cathode. Done. And this is made of tungsten. Why tungsten? Because actually what we are doing, we are heating this tungsten. We are heating it enough. Very much heat we are giving to it. Because of that heat, what is happening? Electron is coming out from this tungsten. Okay. And this coming out electron is further getting accelerated by this is negative and this is positive. So this electron is getting accelerated in this electric field. Done. And this accelerated charge particle is then falling on a sheet made of molybdenum. This is again your atom. You already know about it. So what is happening? It is falling here, and this accelerated electron, when fall on this atom, what is happening? It will transfer its energy to it. Because of that energy transfer, its electron of this atom will rise to the excited state. Again, if it has been to excited state, it will come down to ground state, and while coming down, it will release energy in the range of X. Okay? So we are getting X. Why tungsten? Tungsten, because we are heating it. And if it is made of any other element which has low melting point, it might melt away. But tungsten has very high melting. Why this atom here? This atom we are taking because it has high atomic number. And if it has high atomic number, its energy difference between two states will be higher. Because we have, if hydrogen like element it is acting as, then we can write energy as minus 13.6 by n squared z squared. So energy depends on z ka value. Done. And if this z is more, energy difference will be more. And if energy difference will be more, there is more chance of getting X-rays. Because X-rays ka matlab high energy range. Done. So this will happen in your X-ray tube. Done. So this knowledge you should have. Now what is K alpha, K beta, that I will discuss later. So K alpha, K beta is same as कि आपने Lyman series पढ़ा ना, Lyman series और Balmer series पढ़ा. तो चलो मैं पहले डिस्कस करूँ. ठीक है. अच्छा, डायग्राम I didn't include. So जैसे आपने केमिस्ट्री में पढ़ा होगा, K रेज पढ़ा होगा, L पढ़ा होगा, M पढ़ा होगा. K, L, M, N पढ़ते हो ना, number of cells. Done. So if this is K, this is L, this is M, this is N, and this is my nucleus. Okay. So if an excited electron from anywhere is coming to 1, then it is called K lines. Okay. If from any excited state it is coming to L, then it is called L line. Okay. Now what is K alpha? K alpha means from nearest one wala transition ko K alpha bolenge, means to K first transition can happen from here. Then so that will be K alpha. K beta will be from here to here. Okay. K gamma will be from here to here. Similarly, L alpha will be first transition that can happen to L will be from here. So L alpha will be this. Again, same as Lyman Balmer, only the name is different. Okay. So K alpha. अब निकाल कर बताओ क्या हो. Again here, chalo, let me give you the formula first. So formula for wavelength, जैसे अभी तक हमने हाइड्रोजन के लिए जो भी स्पेक्ट्रम पढ़ा, वहां पे हमने वेवलेंथ को क्या लिखा था? 1 by lambda equal to RZ square 1 by N1 square minus 1 by N2 square. Then same wavelength formula we can use here with a slight modification, and that modification is in your word B. So here Z minus B we write. Done. For K, बी का वैल्यू कितना होता है 1, ठीक है, के लाइंस के लिए, के लाइंस अगर पूछ रहा है तो बी का वैल्यू क्या लोगे 1 लोगे, ठीक है। सो दैट थिंग यू हैव टू डू हियर। अगेन देयर इज वन मोर फॉर्मूला फॉर अदर लाइंस, क्वेश्चन में तुम्हें वैल्यूज दिया रहेगा, डोंट नीड टू वरी अबाउट दैट। सो मोसले लॉ में क्या था तुम्हारा, इन्होंने ये कहा कि जो फ्रीक्वेंसी ऑफ एक्सरे इज गेटिंग जनरेटेड इन पुलिस ट्यूब is equal to k. K is what? A constant. Yes, once. चलो बोलो। हाँ, you can unmute yourself. Yes. Sorry, you're not audible. आप टेक्स्ट कर सकते हो, ठीक है। So what was his saying? उनका फॉर्मूला सिंपल था कि फ्रीक्वेंसी ऑफ एक्सरे गेटिंग जनरेटेड इज इक्वल टू के, अगेन दिस इज अ कांस्टेंट, z minus b का होल स्क्वायर। z is what? Atomic number. So that will be given in your what? That will be given in your question. B value will be 1 for K series and B equal to 7.4. B is a constant. Once B is a constant, again that depends on all the geometry of atoms that we are taking. Again, we don't have to go that deeper. We simply need to remember the values. ठीक है, and value for L series, M series, N series will be given actually, but for K series we need to remember कि B का value 1 होता है. That is easy to remember as well. So frequency का direct formula आप क्या लिख सकते हो? K Z minus B का whole square. ठीक है, so this is your Moseley law. This you need to remember. अब आप यहाँ पे क्वेश्चन करके मुझे बताओ, आंसर लाओगे तुम लोग, कैलकुलेट करो, यू नो द फॉर्मूला नाउ। अनोड मटेरियल का एटॉमिक नंबर पूछा है, यहाँ पे वेवलेंथ का फॉर्मूला आप क्या लिखोगे, 1 by लैम्डा इक्वल टू क्या लिखोगे, व्हाट वाज दैट, आर जेड माइनस के की बात कर रहा है ना, तो 1 होगा डिवाइडेड बाय द वेवलेंथ एक्सरे प्रोड्यूस बाय एक्सरे ट्यूब इज इतना, के अल्फा लाइन बोला है, के अल्फा के लिए n1 इंटू क्या लोगे आप, के अल्फा का मतलब L से K तक जा रहा है ना। सो व्हाट यू विल बी राइटिंग, 1 minus 1 by 2 का स्क्वायर, n2 will become what, 2, n1 will be what, 1, ठीक है। so that you need to put now, do it fast and let me know. ये सबका आर का वैल्यू क्या होता है, आर का वैल्यू क्या होता है, 1.1 into 10 to the power 7 ले सकते हो ना, that is value for R. Lambda is already given now, 0.76 angstrom. Z minus 1 का वैल्यू क्या आ रहा है यार, कैलकुलेशन शुड बी फास्ट, डू इट, वैल्यूज पुट करो ना, 100 by 76 एंगस्ट्रम है, 10 to the power क्या लिखोगे यहाँ पे, -10 इक्वल टू क्या लिखोगे, R 10 to the power 7 Z minus 1 का स्क्वायर डिवाइडेड बाय ये कितना होगा, दिस इज 4 and this is your what 3 है ना. Now calculate this one. चलो ठीक है, that is your task now. Answer you will be not getting this, actually you will be getting 41. Z minus 1 का value you will be getting 40. ठीक है, डन है. प्लीज बी फास्ट विद द कैलकुलेशन, अदरवाइज हम स्टक रह जाएंगे ना ऐसे. तो चलो अब बताओ क्या होगा इसका आंसर. टेक 1 minute एंड डू इट. यस तृप्ति, कैलकुलेशन में फास्ट होना है थोड़ा. ध्यान से करो, ध्यान से सोचो. आई एम गिविंग यू सम 2 minutes फॉर दिस. Means potential difference between cathode and anode is given 20 kilovolt. ठीक है, the minimum wavelength of X-ray generated. Minimum wavelength means highest energy. So highest energy that electron can transfer will be how much? 20 kilo electron volt, right? आर यू गेटिंग मी? जैसे आपने जो ट्यूब पढ़ा ना, चलो मैं ट्यूब को एक बार और दिखाती हूँ तुम लोगों को. यहाँ पे इसको हम लोग क्या बुलाते हैं? ये तुम्हारा टारगेट है. टारगेट क्यों है? क्योंकि वॉट एवर इलेक्ट्रॉन इज गेटिंग एक्सेलरेटेड बाय सर्टेन पोटेंशियल डिफरेंस इज फॉलिंग ऑन दिस सीट, एंड फ्रॉम हियर what this accelerated electron is trying to do here, it is simply colliding with the individual atom, transferring its energy to it, and because of that energy, electron of that atom is getting excited, and again it is coming back to the ground state and releasing energy. So in the question it is given that the maximum potential difference applied is 20 kilovolt. Yani ki potential difference between this point and this point is how much? 20 kilovolt. And if electron coming from this tungsten is getting accelerated through 20 kilovolt, its energy will be how much? You have studied that if Q charge gets accelerated by V volt, its energy will be QV. So if E charge is getting accelerated by 20 kilovolt, its energy will be how much? 20 kilo electron volt. Done. So here energy of falling electrons on the target will be how much? 20 kilo electron volt. So if I'm taking this as an electron, suppose, and this is the target atom I am considering. So these two will collide, and during collision, maximum energy that it can transfer to the target will be how much? 20 kilo electron volt. So this much maximum energy. Okay, Rishabh, ठीक है. ठीक है, चेक करते हैं. आई डोंट रिमेम्बर द आंसर बट इट मे बी करेक्ट, है ना. सो द मैक्सिमम एनर्जी दैट इट कैन ट्रांसफर इज हाउ मच? 20 किलो इलेक्ट्रॉन वोल्ट. मींस दिस इलेक्ट्रॉन एट द ग्राउंड स्टेट, electron inside this target atom, this will receive maximum this much of energy, and because of this it will jump to the highest state. Done. So how much high it is going, that we have to calculate. For that, how much high it can go, whatever high it will go, it will take up how much energy? 20 kilo electron volt. So if that will again come down, suppose it will release how much energy? 20 kilo electron volt. So the photon that is getting released will have how much energy? 20 kilo electron volt maximum. So energy of photon hc by lambda क्या लिखोगे? 20 kilo electron volt. So lambda minimum यहाँ से मिल जाएगा. Done. You simply need to put the values. Again, be careful while putting the values. This energy is in electron volt, and C you will write in meter per second. H you will write as again joule second inverse something 6.34 into 10 to the power minus 34 something. So you need to convert this energy into what? Joule. Okay, everything should be in SI unit. So that complete conversion, okay, Tripti, everyone getting same as that, तो सही होगा सबका. So formula, चलो पहले आंसर नहीं, आंसर हमने लिखा नहीं, सेम होगा जो आप मिल रहा है आपको. But here I have summarized the formula. I have written the exact value. किलोवोल्ट है, हाँ, तो 10 to the power 3 भी मल्टीप्लाई करोगे ना, ठीक है. चलो डन है. So this two formula I have written here, this one and this one. So when we will be using this one and when we will be using this one. So this one we will be using for the case right now. So what is the case? If accelerated electron is falling on target and exciting टारगेट इलेक्ट्रॉन, ठीक है, तब जो भी वेवलेंथ निकलेगा उसका वेवलेंथ हम लोग ऐसे निकाल सकते हैं, where V is what? V is your voltage, ठीक है. And what is this? This must you have studied, ठीक है. अच्छा, once एक second, just give me 1 second, ठीक है, मैं explain करती हूँ. So this wavelength is for what? This must you must have studied this while reading de Broglie wavelength. What is the formula for de Broglie wavelength? H by P. Again, if we are going to write this de Broglie wavelength for electron that is getting accelerated through V voltage, ठीक है. So that if question is given like there is an electron and that is accelerated through V voltage, what will be its de Broglie wavelength? Then you will be putting the values like 1.22 by root under P nanometer, and here we will be the voltage through which electron is getting accelerated. Done. So it is for calculating what? De Broglie wavelength. Done. And that too for electron accelerated by V volt. Okay. So formula again we need to be very careful about. Yes, once आपका doubt क्या है? Why kilo electron volt you are talking na? Here kilovolt it is written na. Electron is getting accelerated by 20 kilovolt. It is kilovolt. तो यहाँ पे मुझे लिखना होगा एनर्जी ऑफ एक्सेलरेटेड इलेक्ट्रॉन, जैसे मैंने बोला ना, इफ क्यू चार्ज यू आर एक्सेलरेटिंग बाय वी वोल्टेज, इट्स एनर्जी विल बी क्यूवी. So if E charge means one electron, that is E charge, is getting accelerated by 20 kilovolt, its energy will be 20 kilo electron volt. Done. Again, if you have to convert it into joule, you will be writing 20 into 10 to the power 3 into 1.6 into 10 to the power minus 19 joule. Done. Again, you don't need to put it here time and again. I have simplified this thing. So lambda you can directly write in case of X-ray tube 12375 by V. If in the X-ray tube it is given that electron, falling electron, is getting accelerated by V voltage, then what wavelength we will get from the after electron will hit the target atom and it will excite certain electron, and after excited electron will come down to the ground state, it will release photon. What will be its wavelength? So that we can write here. I hope you people are getting. किसी को doubt है? Anyone having any doubt? देखो एक्सरे से अगर डाउट है तो पूछ लो, किसी को भी डाउट है तो मुझे बता दो एक बार प्लीज. आई एम गिविंग यू सम टाइम. कंस्ट्रक्शन लाइक एनोड कैथोड बेसिक कॉन्सेप्ट समझने में अगर प्रॉब्लम है, इफ यू आर हैविंग एनी डाउट लेट मी नो. नहीं है तो भी नो लिख दो. Once, is it clear? Okay, done. चलो ठीक है, आगे बढ़ते हैं. So now do this thing. Again, this is a deep concept actually that we need to explore. But आपने पढ़ा जरूर होगा. केमिस्ट्री में भी पढ़ा होगा। चलो, I'm going to discuss it actually without wasting any time. Just give me some seconds. This is a concept actually. जैसे देखो, आपने जरूर दो चीज पढ़ा होगा. No. Just look at this thing once. Suppose I'm taking two cases. ठीक है, एक मैंने लिया हाइड्रोजन का एटम, गैसियस एटम लिया. ठीक है, एक गैसियस एटम. Done. This I'm doing. Another what I'm doing ना, कि एक और मैंने यहाँ पे सपोज मैं एटम लेती हूँ एंड दिस इज माय सॉलिड हाइड्रोजन है. सॉलिड का मतलब इसके आसपास बहुत सारे क्लोज में क्या होंगे, एटम्स होंगे. गैसियस एटम मैंने लिया, इसका क्या मतलब है कि स्पेस और डिस्टेंस बिटवीन टू हाइड्रोजन एटम विल बी लार्ज. सॉलिड हाइड्रोजन एटम मींस डिस्टेंस बिटवीन टू हाइड्रोजन एटम विल बी वेरी क्लोज. Done. So that is the difference. Now, why I have taken this? Suppose what I'm doing now, I'm just hitting this hydrogen atom with accelerated electrons. ठीक है, these are energetic electrons, and with this I'm hitting this. ठीक है, या फिर कोई भी एक energetic charge particle ले लो. ठीक है, उससे हम लोग इसको क्या कर रहे हैं, हिट कर रहे हैं. अब हीटिंग के टाइम पे क्या होगा, same as what was happening inside the Cooley's tube. While accelerated electron was hitting the target, same thing will happen here. Done. So if same thing is happening, what will happen? There will be a ground state and there will be so many excited states like that. And initially, when there was no charge particle falling on it, what was the case? Its electron must be in the ground state. It must be stable. After hitting, it will gain some energy. Its electron may jump to the excited state. Done. And if it is jumping to the excited state, where it can jump? Suppose कि ये जो पहला charge है ना, it is like for case of hydrogen, difference between these two energy level is how much? 10.2 electron volt. है ना? If I'm not wrong, this is this now. Yes. So this is this. Now suppose this charge particle is giving it energy 9 electron volt. So if this electron is gaining 9 electron volt of energy, it will jump to where? 9 electron volt की कोई घर है? Is there any space having energy 9 electron volt? नहीं. This difference is 10.2 electron volt. So the first home is here. First home for this electron is here, other than this. So if it is leaving its original home, it will go to what? Second home, third home. So the very first home that it will encounter in the way is how much away? 10.2 electron volt away. And if it is getting only 9 electron volt, it will not make any jump. क्योंकि वो हवा में रह जाएगा. और हम हवा में jump करके कहाँ जाएंगे? अगर घर ही नहीं है तो we won't jump. Done. So this energy won't accept. Done. It will remain here. But if this charge is giving it this much energy, it will jump here. And while it will come down, it will release energy of photon 10.2 electron. Again, if it gets this much energy, it will go to the n equal to 3. It will go to this home. And again, it is in excited state. It will come down and it will release energy of this range, right? And if it goes to n equal to 4, again, here it will come back again releasing energy of this much difference. So what you can observe here, observation is that कि जो emitted photon है, that photon will not have all energy. It will either, that photon will either have this difference of energy, this difference of energy, or this difference of energy. Certain differences होंगे ना, 9 electron volt का photon नहीं मिलेगा, 8 electron volt का photon नहीं मिलेगा. So continuous energy of photon we are not going to get when this electron is going to get excited, right? Only discrete energy we will be getting. Discrete means only some values, not all values. So there is a two term in a spectra, that is, one is your continuous and another is your discrete. So what is difference between these two? कंटिन्यूस को बाद में डिस्कस करते हैं. लेट्स कम फर्स्ट टू द डिस्क्रीट. सो व्हाटएवर स्पेक्ट्रा हियर वी आर गोइंग टू गेट बिकॉज ऑफ excited electron coming back to the ground state, that spectra will only have certain energy, not all energy. So that is discrete spectra. Okay. So only discrete energy we will be getting. Then now what if the same charge is hitting this? तो सबसे पहले तो हमें ये सोचना होगा कि this atom, if this atom will have same energy diagram as that of this, एक gaseous atom है. Just see carefully. There is a gaseous atom. So it has a nucleus of positive charge. It has electron here and another atom is here. So distance between its nucleus is very far. Distance between electron of these two is also very far. Done. So there is a very less chance that this atom will interact with this atom. Done. And if no interaction is happening, ideal gas का मतलब क्या होता है? No interaction happening. Done. So the first case I have taken is I have taken an atom from an ideal gas. So no interaction will happen between these two atoms. Means no electrostatic interaction. If no attraction between this nucleus and this electron is happening, no attraction, no repulsion between this electron and this electron is happening, then what will happen? Whatever energy this atom is having will have, its energy is not going to change because of presence of other atoms around, because it is not interacting with other atoms. Then now second thing, suppose we have a charge Q and this charge Q has some energy, suppose E energy it is having. Then now what I am doing now, I am bringing very a positive charge very close to it. Then so what will happen? Repulsion. Again I have told you, if repulsive force is there, their energy will what? Increase. So if repulsive force, if it starts receiving some repulsive force, its energy will what? Increase. And if I'm bringing here some negative charge, attraction will happen and its energy will decrease. So its energy will get affected by presence of surrounding charges if surrounding charges are very close. Now in the case of solid hydrogen atoms are very close. Then so much close that if I am focusing on one hydrogen atom, suppose I am focusing on this one, it has a nucleus, right? So its nucleus has a positive charge, it has an electron here. And this electron will feel repulsive force because of other electrons. Done. Oh my God, what topic I am discussing? यार मैं डिस्कस कर रही हूँ एनर्जी बैंड कैसे ब्रेक करेगा. ठीक है, जस्ट लेट मी डिस्कस. कॉन्सेप्ट समझ में आ रहा है ना? मैं अभी लॉस्ट कंक्लूजन पे आती हूँ. ठीक है, जस्ट गिव मी 1 सेकेंड मोर. सो यहाँ पे देखो दो चार्जेस के बीच में क्या हो रहा है? रिपल्सन. सो डेफिनेटली energy of this atom will get influenced, either it will increase, it will decrease. Done. So in semiconductor, you have studied now, once you have studied, there was a valence band, remember, and there was a conduction band. What was this band actually? Band means this was an energy band. Done. So that atom was having energy, this level of energy it was having, and band है इसका मतलब क्या है कि अगर यहाँ पे एनर्जी -13.6 इलेक्ट्रॉन वोल्ट है, सो इट इज हैविंग ऑल लेवल्स ऑफ एनर्जी लाइंग बिटवीन -13.6 टू E. ऑल एनर्जी आर प्रेजेंट और एनर्जी लेवल्स आर प्रेजेंट. जैसे अभी हमने एटम का एनर्जी डायग्राम कैसे बनाया? एक n = 1 बनाया, यहाँ पे n = 2 बनाया है ना, यहाँ पे n = 3 बनाया. So there was no home in between 2 and 1. It means there was no energy level present here. But in case of solid, what happens? You will get energy level at every point. There will be home continuously. So that is your energy bands that you must have studied in your semiconductor. अगर आपने पढ़ा होगा तो it must be there. So मैं यही कहने का कोशिश कर रही हूँ कि जो solids होते हैं ना, वहां पे energy bands will not be discrete as we have studied so far. n = 1, n = 2 में gaps नहीं होंगे. There will be continuously energy levels, and so energy bands उसको हम बुलाते हैं. Done. So if light is falling, if charge is falling on atom, solid atom, what will happen? It's all energy, for all energy of electron falling here, there will be a transition inside this atom because it has continuous energy levels. So if continuous energy levels are there, so this excited electron can jump here, and also home is there also. So it can jump to any level. Done. And if it is jumping to any level, it will come down also, and while coming down, it will also generate energy of any sort. So continuous energy we are going to get in case of solid atom. Done. And inside X-ray tube, if you remember the diagram में this was a solid, right? This is what? A solid thing. Done. So if there is a solid thing, what will be the answer now? Give me the answer now. It will have all wavelengths larger than a certain minimum wavelength. Done. Certain minimum wavelength के अंदर मतलब आपने जो conduction band पढ़ा है ना, this is valence band and this is conduction band. तो conduction band का तो मतलब होता है कि इलेक्ट्रॉन एटम से बाहर आ गया, बट अगर इलेक्ट्रॉन एटम के अंदर ही है, दैट इज सिर्फ एक्साइट हो रहा है, तो मैक्सिमम एक्साइटमेंट कहाँ से हो सकता है? यहाँ से यहाँ. डन. सो मैक्सिमम एनर्जी ये, यानी कि ये मिनिमम वेवलेंथ होगा. डन. सो इस मिनिमम वेवलेंथ से और मिनिमम वेवलेंथ हम नहीं ऑब्टेन कर सकते, बट इस मिनिमम वेवलेंथ से लार्जर कोई भी वेवलेंथ मुझे मिल जाएगा. डन. सो द करेक्ट आंसर विल बी. ठीक है. सो दीज आर एक्चुअली कॉन्सेप्ट्स दैट यू नीड टू नो फॉर दिस एडवांस थिंग. ठीक है. ये कंटिन्यूअस और डिस्क्रीट का ऑप्शन का कॉन्सेप्ट पता होना चाहिए. तो मुझे बताओ कितने लोगों को समझ में आया? यार प्लीज let me know. Okay, Nitin. Others, please. Got it now? Thank you so much. Thank you. It's very helpful मेरे लिए. Discrete continuous spectrum मैंने सारा डिस्कस कर दिया. नाउ एनर्जी डिफरेंस ये तो अब तुम लोग बना लोगे. ठीक है. So that you will be doing. चलो अब हम लोग न्यूक्लियस पे आते हैं. डन. न्यूक्लियर फिजिक्स पे आते हैं. From here it will start. तो सबसे पहले इसका आंसर बताओ. सबको पता होगा ये, तो ये सबको पता. आई एम जस्ट गिविंग सम. इतना टाइम भी मैं क्यों दूं? 30 सेकेंड, 15 सेकेंड, 15 सेकेंड. राइट द आंसर सिंपली. Yes, once. Very good. If you remember, you will be giving me the answer. चलो नहीं आ रहा तो मेरा भी वेट करने का कोई मतलब नहीं है ना, क्योंकि इसका मतलब याद नहीं है. रेडियस ऑफ न्यूक्लियस का क्या फॉर्मूला है? इफ दिस इज नॉट एटम आई हैव ड्रॉन, दिस इज न्यूक्लियस. सो व्हाट इज द फॉर्मूला फॉर रेडियस ऑफ न्यूक्लियस? R इक्वल टू R नॉट A का पावर 1/3, where A is the mass number of nucleus. R naught is a constant. 1.2 into 10 to the power minus 15 मीटर. So nucleus इस रेंज में होता है. फेम्टोमीटर के रेंज में न्यूक्लियस का रेडियस होता है. ठीक है. नाउ रेडियस इज दिस. सो न्यूक्लियस का वॉल्यूम क्या लिखोगे? वॉल्यूम शेप क्या होता है? सॉलिड स्फीयर की तरह ले सकते हैं. सो व्हाट विल बी द वॉल्यूम? 4/3 पाई r क्यूब. So what will be the value? 4/3 pi. R क्यूब करोगे तो क्या हो जाएगा? R नॉट का क्यूब. A का क्यूब करोगे तो क्या होगा? A हो जाएगा, क्योंकि 1/3 है यहाँ पे. डेंसिटी क्या होता है? मास बाई वॉल्यूम. मास ऑफ न्यूक्लियस मास नंबर के बराबर हुआ. वॉल्यूम कितना आया? इतना. A कैंसिल हो गया. सो डेंसिटी इज इंडिपेंडेंट ऑफ मास नंबर. ठीक है. सो द रेशियो ऑफ मास डेंसिटी. मास डेंसिटी पूछा था ना, मास पर यूनिट वॉल्यूम, सॉरी. So it will be same for all the atoms. So one ratio क्या हो जाएगा? 1 same for all atoms. 1 होगा आंसर. This is the formula. चलो अब ये बताओ. अब हम लोग सिंपली मेमोरी को जॉब करेंगे. ठीक है. बीटा प्लस बीटा माइनस डीके अल्फा डीके क्या क्या जनरेट होता है. चलो बताओ यहाँ पे एक्स किस चीज के लिए स्टैंड करेगा? जल्दी से बताओ. याद है तो जल्दी से आंसर करोगे. हाँ, जस्ट आई नीड टू चेक योर मेमोरी. बीटा प्लस डीके है. बीटा प्लस डीके में क्या होता है? बीटा डीके में क्या होता है? आइदर न्यूट्रॉन प्रोटॉन में डीके करता है या प्रोटॉन न्यूट्रॉन में. नाउ टेल मी द आंसर. This is beta plus decay. So in beta plus decay, what will happen? चलो याद नहीं है तो चलते हैं आगे. और बीटा डीके में क्या होता है? दो तरह के डीके हैं, बीटा प्लस एंड बीटा माइनस. बीटा माइनस डीके में क्या होता है? न्यूट्रॉन जो है वो प्रोटॉन में कन्वर्ट, और साथ साथ क्या जनरेट होता है? टू अदर एलिमेंट्स विल गेट जनरेटेड. दिस इज योर इलेक्ट्रॉन and this is your anti-neutrino. Again, this is a neutral particle. This is a neutral particle. Done. And this is almost massless. Almost massless. And if anything is massless ना, बहुत छोटा मास है, जैसे एक दरवाजा ले लो. सपोज करो तुम्हारे रूम का दरवाजा है. सो तुम्हारे रूम के दरवाजे में हाथी आएगा? हाथी. हिप्पो आएगा? नहीं आएगा, बिकॉज देयर डायमीटर इज वेरी लार्ज ना. डन. सो मास जितना ज्यादा होगा, उनका हर जगह घूमने का प्रोबेबिलिटी उतना कम होगा, है ना. इफ मास इज लेस, इट विल पेनिट्रेट एनीवेयर. डन. That is why anti-neutrino will penetrate to larger distance. Done. Because its mass is what? Its mass is very less, and it's also neutral, so it won't get deflected by positive or negative charges present in the atmosphere. So it has very large chance of penetrating to large distance. Okay? This is electron, you know, mass, charge, everything. Now, what is this? Your yes, once E plus is your positron. ठीक है. इलेक्ट्रॉन का ही भाई है वो, बहन भाई जो भी बोलो. इलेक्ट्रॉन और पॉजिट्रॉन क्या होते हैं? दोनों एक दूसरे का एंटाई पार्टिकल्स हैं, दोनों एक दूसरे का ऑपोजिट है. ठीक है. एक के पास जितना नेगेटिव चार्ज है, दूसरे के पास उतना ही पॉजिटिव में चार्ज है. इसके पास कितना नेगेटिव चार्ज होता है? इतना. और इसके पास इतना ही पॉजिटिव चार्ज होता है. सो दिस इज पॉजिट्रॉन, एंटाई पार्टिकल ऑफ इलेक्ट्रॉन. What is the property of antiparticles? If two antiparticles are coming together, what will happen? They will get destroyed. So here, if two antiparticles come together, what will happen? They will annihilate each other. They will destroy each other. They will simply get converted into light. That's the answer. Okay? So that will happen. Again, this is what? Neutrino. Again, this is antiparticles of antineutrino. ठीक है. इतना ही याद रखना है, ज्यादा नहीं याद रखना. बीटा प्लस में क्या हो रहा है? प्रोटॉन इज गेटिंग कन्वर्टेड टू न्यूट्रॉन. सो इफ देयर इज एन एटम ZA something kind of, so if beta plus decay is happening, what will happen? Its one proton will get converted into neutron, so its atomic number will decrease, है ना. If beta plus decay is happening, its atomic number will decrease, but what will happen to the mass number? Mass number क्या होता है? Neutron plus proton. So in beta decay, proton is getting converted to neutrons. So overall number of neutron plus proton will remain same. So mass number won't change. Be it beta plus decay or beta minus decay. Beta minus decay में क्या होगा? Neutron will get converted to proton. So its Z will increase by 1. But again, mass number will remain same. So here Z increases by 1 and here Z decreases by 1. But A is constant throughout. ठीक है. अब चलो ये दो क्वेश्चन मुझे जल्दी से करके इसका भी आंसर बताओ. वंस नहीं, व्हाट आई सेड ना, यहाँ पे बार जो है ना, ये एंटाई पार्टिकल बता रहा है. ठीक है. दिस इज योर एंटी न्यूट्रिनो. न्यूट्रिनो का सिंबल ये होता है. ठीक है. अगर एंटी बोलना है तो क्या बोलोगे? ऐसा. ठीक है. सो दीज आर सिंबल्स. ठीक है. चलो, दिस इज द लास्ट क्वेश्चन ऑफ टुडेज क्लास. करते हैं इसको. अगेन यहाँ पे भी आपको क्या करना है? मेमोरी को ही रिकॉल करना है. डू इट. बीटा रेज एमिटेड बाय रेडियो एक्टिव मटेरियल. बीटा रेज का मतलब क्या हुआ? इलेक्ट्रॉन एंड पॉजिट्रॉन. ठीक है. बीटा रे का मतलब क्या हुआ? इलेक्ट्रॉन एंड पॉजिट्रॉन. सो बीटा रेज एमिटेड बाय रेडियो एक्टिव मटेरियल्स आर व्हाट? चलो आ गया एक आंसर तो मिला शायद. ऋषभ. यस. व्हाट? यस. तृप्ति. वंस. यस. गो फॉर सेकंड में जाओ. सेकंड इक्वेशन इज इक्वेशन ऑफ व्हाट? सो फर्स्ट का ऑप्शन क्या होगा? सी होगा, क्योंकि बीटा रेज क्या था? जब मेरा न्यूक्लियस में व्हाट वाज हैपनिंग इन बीटा डीके? neutron was getting converted to proton or proton to neutron. And in this processes, what was happening? Positron or electron was getting generated. So basically charged particles emitted by nucleus. ऋषभ नहीं यहाँ पे क्या हो रहा है? बीटा डीके में क्या होता है? प्रोटोन न्यूट्रॉन या न्यूट्रॉन प्रोटोन में कन्वर्ट होता है, लेकिन यहाँ पे देखो एटम्स कंबाइन हो रहे हैं. जस्ट लुक केयरफुली, 4 एटम्स ऑफ हाइड्रोजन. यस, ये once see carefully ना, 4 atoms are coming together. Fission और fusion पढ़े हो ना? What happens in fission? Yes ऋषभ, fission में क्या होता है? Yes तृप्ति, fission में एक atom break करता है 2 में. This is your fission. And what happens in fusion? Fusion में क्या होगा? 2 atoms will combine together and they will make a larger one. That is fusion. Done. Fission में कुछ ऐसा, fusion में कुछ ऐसा. So this is definitely fusion, not fission. अनुष्का, fission नहीं होगा ना? Fission में atoms पास में आके combine नहीं होते ना? Fission में क्या होता है? Break होते हैं. ठीक है? So in the next class, I will be discussing a bit more of the general concept for half an hour, and for another 1 hour, we will be taking up questions. मतलब big questions of recent years. ठीक है? That we will be doing. Yes, once. चलो ठीक है. Anyone having any doubt? Just last 1 minute. Doubt? किसी को कोई परेशानी, कोई problem? If having any doubt, let me know. Next lesson में modern physics only we will be taking up now. For next 2 classes, we are going to stay with the modern physics. Okay, Tripti, thank you. Tomorrow I will be taking up 1 question from gravitation. Okay, very first question will be from the gravitation. Then we will be moving on to what is that? Modern physics. Okay, done. Bye bye. Take care, everyone. Stay happy. Stay positive. Only focus should be on the work. So do work. उसके अलावे